Hello, everyone, and welcome to Netcracker. Here again, I am with a new subject which we are going to teach you, and it is one of the most important topics which are asked in UGC NET exam and CBSE NET exam. So, what is the subject? It is data structures. So, as you would have seen, number of question has been asked in past from this. So, my focus is going to be on the main and the core part of these subjects, which are like regularly asked in paper. So, my point of view is that I will just be focusing on the questions, like what type of questions are asked in exam from which topic. So mainly I will be there for helping you to solve questions like which are asked. And for theory, like I will be touching on main important topics, but for most of the theory you need to study your books. But as a concept wise, I will be making it clear. So let's begin, and I hope that you keep a track of all the notes and all the points which I will be telling you, and along with that I will be solving few questions which are asked in previous exams. So let us begin with no delay. So what do we mean by data structures? Like, we know that we need to store our data, and for that we have been provided with number of data types and number of ways in which we can store it. So the organized collection of data in a mathematical or a logical way is called as data structure. Fine. So this is a way in which we store our data. So the basic things which are related to data structures is that a data element, it is the building block, or we can say it is a field in which data is stored. So that is called as data element. And data types, as we have studied earlier, like in C language or in any other language, you would have studied that the data types are like integer, float, boolean, character, etc. So now what do we mean by algorithms? These are the set of rules that defines how a problem can be solved in a finite steps. So what do we mean by algorithm? These are the number of steps which are like always told before solving any problem, with the help of which we can solve our questions. So what are the types of data structures? There are two types of data structure. One is linear data structure, other is non-linear data structure. As the word linear means in a line, so array, linked list, stack, and queues, these are the examples of linear data structure. And non-linear data structures are like tree, graphs. Fine. So just briefly I will be discussing all these data structures. So firstly we have array. Array are the data structures which stores homogeneous data, or which we can say that the data which is of similar type, they are stored in array. And we know that array can be of two types, one dimensional and two dimensional arrays. Fine. So I'm not going in much detail, but just to introduce all these things. Now we have linked lists. It is a dynamic data structure, and it means that memory to hold data is created at runtime. So it means that as soon as we create any linked list, it doesn't get stored into the memory at that point of time only. It is stored when we run that program. So how do we represent a linked list? Over here, all these are called as nodes, and node is divided into two parts. One is the data part and the other is link part. So data part stores the actual value of the data, and link stores the address of the next node which is linked to it. Fine. And at the end, where the our linked list ends, we have a null value over there. So what we can say, that linked list is a chain of structure which contains a pointer to the next element. So this is a pointer which is telling the next element that where it is. Fine. So the next one which we have, it is a stack. So you would have heard this term stack so number of times, and this is one of the most important data structure, and many questions are asked in exams regarding this. So today I will be discussing stacks and some questions on this as well. Fine. So stack represented by an array or a linked list and is based on the methodology of last in first out. So what do we mean? The data element which is entering last will be the first one to move out of the stack. And to do these operations, we have push and pop. Push means inserting the elements into the stack, and pop means removing or deleting the elements from the stack. So this becomes our top of the stack, and over here it is the bottom. So the next one which we have is a queue. It allows the access to only to the front and back of the stack. So it means that it has two points, at front and at rear end. So at the front we can do all the deletions, and at the rear end we can insert the elements. Fine. Then the next which we have are the tree and graph. I am not discussing over here these data structures, because there is going to be plenty of talking about these two in full detail, because most of the questions are asked from these two places. Fine. So without any further ado, today I will just take stacks, and this is the way we can solve these questions on stacks. Here we have the way we solve stacks. So this is the operation of stacks, in which we can express our expression in three forms, whether it is infix, postfix, or prefix. So what do we mean by infix? Infix means that the operator is present between two operands, and in postfix the operator occurs after the operands. In prefix we have the operator before the operands. Fine. So this is how we represent these three: infix, postfix, and prefix. So how to convert any infix to postfix? How can we do that? So here is the expression, right? So firstly what we need to do is we need to follow this precedence. This is the precedence chart, in which we have to solve brackets, then indices or exponential, then division, multiplication, addition, and then subtraction, right? If any expression having brackets, then that bracket will be solved first, and after that indices will be solved, then division, then multiplication, addition, and subtraction. Fine. So just look at over here. Firstly, we will solve these expressions inside the bracket. So a plus b becomes ab plus, and here d minus e becomes de minus, and f plus g becomes fg plus. So this is the postfix notation inside the bracket. Fine. So after solving this bracket, now we need to solve the bigger one, right? So to do that, what we have to do, this becomes one term and this is the another term. So here we have two operands, as you can see, operators, multiplication and minus. So we know that we will give preference to multiplication as it has higher precedence. So what we do, a b plus remains as it is, and then we move this multiplication sign here. So we get a plus b c into minus, then the bracket remains same as it is. Fine. In the next step we can see that we need to perform the postfix inside this bracket itself. So now we are left with this minus sign. So we write a b plus c into, then this minus signs moves from here to the end. Fine. So it becomes de minus minus. This sign is moving here, so we represent it over here like de minus minus. Fine. So and the rest of the figure remains the same. Now again we have this bracket and this bracket. We need to solve these two, and we in between we have dollar. So what happened, we write this as it is over here and move this dollar sign from here to the end and make it into postfix. So finally our answers become this, right? In similar manner, here is one question which was asked in December 2014 in paper 2. So this is one of the famous questions, like this postfix notation. It is like many times it has been asked. Fine. So one question I am solving here. It means a plus b exponential d divided by f minus e minus f plus g. So first thing first, we are going to solve the brackets. All the operators inside the bracket will be solved first. So as we know, over here we have plus and this exponential sign. So which has the greater precedence? We have exponential or indices has the greater precedence. So we move this from this sign from here to the last, to the end, and make it postfix. So it becomes a plus bd and this sign. Then we write over here by solving this portion, we get ef minus and plus g, right? And after that, what happens over here, as we can see that we are left with this plus sign inside the bracket. So even this needs to be moved to the end. So what we do, a b d exponential and this plus, and we keep the bracket as it is. Fine. And over here, as we can see that we have ef minus bracket plus g, and in between we have this division sign. So the precedence of division and plus, we need to compare these two. So division has higher precedence and addition has lower. So what we are going to do, we are going to solve these two first. Fine. So what we get, a b d and exponential plus, and we take this ef minus as it is and move this division sign from here to the end of this element of this bracket. So we get this as the expression, and plus g remains as it is. And in the end, what we can say, that we are left with this plus sign. We will simply move it to the end of g and we get it over here, and the whole expressions become this: a b d exponential plus ef minus division g plus. Fine. So according to the question, our option A was the correct answer for this. In the similar way, we can convert infix to prefix. So how can we do that? The same expression which was written above, the first example which we had taken, the same expression is here, but in this, what we are going to do, we are going to prefix. So which means that we will prefix our operators. So it means that firstly we will solve the bracket in the similar manner as we have solved in our previous question. So it becomes plus AB into C, and inside the bracket again we get minus DE. We move this plus signature to the beginning. So we have moved our plus from here to here, and it becomes minus DE. And over here inside the bracket again we have F plus G. So we move our plus in the prefix and we get plus FG. Fine. So the brackets are partially solved now. Now what we have left? We are left with multiplication minus and this dollar sign. So as we know that multiplication has higher precedence, so we will perform this first. So we are moving our multiplication from here to prefix to here. Fine. So we are moving it from here to the starting. So it becomes multiplication plus ABC. This C comes as it is and moving our multiplication from here to here. Right. Then we have this minus as it is, and the whole expression is left as it is. Now we are left with minus and this dollar. So we know that we are going to solve this minus first. So what happens? We take this minus sign and move it to the beginning of our expression because it is prefix. So we are get our answer as minus multiplication plus ABC, and this DE comes as it is inside the bracket, dollar and plus FG. So now as we can see, we are just left with this portion and this portion with the dollar sign. So now we need to move our dollar to the starting for making it into prefix notation. So we get dollar minus multiplication plus ABC minus DE plus FG. So this is how we do our infix to prefix notation. Fine. Now here is another way of doing our question, and this is also one of the types in which we can be asked our questions. So this is the postfix into infix. Fine, for doing this we have 3 steps. Firstly, count the number of characters present in expression. Fine, we count the number of expressions inside the expression. So how many are there? 1, 2, 3, 4, 5, 6, 7. Fine, we have 7 elements in this expression. Now make a stack of that size. So we have made a stack of width of size 7. After that, place the left hand side characters of the expression on top and right hand side characters at the bottom. So left hand side characters are placed at the top of the stack, fine, and the rightmost are placed at the bottom. As you can see here, we have placed it at the bottom. So now what we will do next, empty the stack until any operator occurs. Okay, we will empty our stack until any operator occurs. When operator occur, then place that operator between last 2 variables. So what do we mean by this last step? It means that we have a stack with the elements, fine. So we need to empty it out. So how are we going to do? We are going to use a pop operation, right? So we have popped our A, B plus, right? So here is the condition. It says empty the stack until any operator occur. So here an operator has occurred. Plus is an operator. When this occur, what we are going to do? When operator occurs, then place that operator between the last 2 variables. So here, as you can see, just forget this part over here. So A, B and plus we had. As soon as the operator occur, place that operator between the 2 variables which were previously occurring. So we have placed our placed our plus in between A and B. So we get A plus B. Fine. And after that, start with the popping again and empty out the stack. So we have C, we write C, we have D, we write D, then we have minus, we write minus, and we keep on popping unless and until we get a operator. So minus is an operator. When an operator occur, what we are going to do? We are going to place this operator in the last 2 variables, between the last 2 variables. So we had C and D. These are the last 2 variables which were occurring. So this minus will be placed in between C and D. So here you can see the expression which becomes A plus B, C minus D. Fine. So now in the stack, we are just left with the multiplication. So we have taken this out in the next step. So we pop unless and until an operator occurs. So multiplication is an operator. It has occurred. So it will be placed between the last 2 variables. So as we have placed all these things in bracket. So this is a single term and this is another term. So this multiplication will be placed in between these 2. So this is our expression which we get. A plus B into C minus D. Fine. So this is how we do our postfix into infix. These are the 3 steps which you need to remember and how we do. I will just quickly revise them again. Firstly, count the number of variables or number of terms which you have in the expression. Make stack of that size and write these expression by left hand side elements at the top and right hand side at the bottom, right? And then pop the elements unless and until any operator occur, and whenever an operator occur, just place them in between the last 2 variables present. Like plus occurred, so we place this plus in between A plus B. In the similar way, we popped out our C and D, like C and D, and then a minus occurred, so we place this minus between the last 2 occurring, which were C and D. These are the 2 last occurring variables, so we placed a plus minus in between C and D. In a similar way, we did with multiplication as well, so we ended up with this. Now I will solve another question which was asked in 2016 in paper 2, and this is another type of question which can be asked from stacks. So here we have considered the following operation performed on a stack of size 5. Fine. we have this push, pop, push, pop, push. I will be doing this question, and we had been given 4 options, and we need to find out which is the most correct one. So I will just perform this question in front of you. Like, we have a stack of size 5. Fine, 1, 2, 3, 4, and 5. So it says push means insertion, so we pushed A. Then it said pop, so we pop A out. So we are left with an empty stack now. Fine. So we did this, we did this. Then push B. So we had nothing in our stack, so I write B here. We have pushed B, then push C. I have pushed C, then pop. I have popped C, then again push D. So what was there left in the stack? It was just B. So after popping out C, right? So we are left with, we need to push D. So I have pushed D, then pop. So I pop out D, then again it says pop. So I was having B in our stack, so again I pop, and then at the end again we have push E. So I write E here. So what are the options we can see? Underflow occurs. No, there was plenty of space. No underflow occurred. Then stack operation are performed smoothly. Overflow occurred. None of the above. So I think that it should be stack operations are performed smoothly, because there is no problem while performing these steps. So this is the another type of a question which can be asked. Fine. So just remember, in stacks, that you need to perform infix, postfix, and prefix notation, and there are 2 operations, push and pop, and regarding these 2 things only mostly the questions are asked in exam. So thank you for joining, and in the next lecture I will be teaching another topic in data structures. So let us meet up over there, and till then, all the best and enjoy. Thank you.